Okay, we're now coming on to the most difficult aspect of tree diagrams. And depending on where they choose to put this particular type of question in the paper will depend on how difficult it is. If they're feeling nice, they might put a nice independent event question somewhere towards the middle of the paper. You might possibly have a dependent event ones, just after the staples, as it were, a little bit towards the end of the paper. But they can, if they want, make these kind of tree diagram questions really quite difficult. So in this next few videos, I want to look at some of the most difficult kind of tree diagram questions that they can do. This particular question is a really famous one. It's famous because back in, oh my goodness, I think it was 2015, the government made the GCSE maths a little bit harder. And this particular question was so famous it made the news because it was the first time when the exam board did questions that were like difficult that kind of like combined a couple of things together. So here we've got like quadratic equations and algebra combined with tree diagrams. And at the time it was quite controversial, and lots of people on the news were saying, oh, my dad's an accountant and he couldn't do the question. So it's quite a famous question, this one. So it says, there are n sweets in a bag. 6 of the sweets are orange and all of the rest are yellow. Hannah takes at random a sweet from the bag and she eats the sweet. Okay, so Hannah takes a sweet from the bag and she eats the sweet. Okay, now we're told that the probability that Hannah eats 2 orange sweets is a third. So let's have a look at drawing the tree diagram for selecting 2 orange sweets. So first of all, we know that there are 6 orange sweets in the bag when Hannah first reaches in there to take one out. And we know that there's n sweets in the bag. So the probability that Hannah selects an orange sweet is 6 over n. Now, therefore, we don't need to know all these other branches, but I'm just going to show you how you would fill them in because there are exam questions where you do need to know this. So the probability of Hannah selecting a yellow sweet would be n take away 6 over n. So that would be the probability of a yellow sweet because there's n sweets in the bag, 6 of them are orange, so therefore it must be n take away 6 that are yellow. So that's how you would do the first branch. Let's look at the second branch. If Hannah had selected an orange sweet or eaten an orange sweet, then there would only now be 5 orange sweets in the bag when she reaches in the second time, and there would only be n minus 1 sweets in the bag as well. So we've got 5 over n minus 1. Okay. Now, again, so we only need these two actually for answering this question because we're told that the probability is a third. But just for our interest, I'm just going to describe how you would fill the other ones in if you had to. So the probability that Hannah selects a yellow sweet. Now, if Hannah had eaten an orange sweet first, there'd still be the same number of yellow sweets. So there would still be n minus 6 yellow sweets in the bag. But the number of sweets in the bag has gone down by 1. So the probability of Hannah selecting a yellow one, if she ate an orange one first, would be n minus 6 over n minus 1. Now let's imagine that Hannah selects eats a yellow sweet first. What's the probability that she selects a yellow sweet the second time around? Well, there's 1 less in the bag, so instead of n minus 6, it would be n minus 7. And there's 1 sweet less in the bag, so instead of being n, it would be n minus 1. Okay. Now, the probability that Hannah selects an orange sweet if she ate a yellow one first is, well, there would still be 6 orange sweets in there. So it would be 6, but there are now only n minus 1 sweets in the bag. So if you had to, for a particular question, as you may well have to, that's how you would complete all of the different aspects of that particular tree diagram. However, in this question, they tell us that Hannah eats, the probability of Hannah eating 2 orange sweets is 1/3. So let's have a look at that. Now, we know from our work earlier in this topic that when we think about the word and, we multiply. So we've got 6 over n is the probability of orange, and another orange is going to be, we're going to multiply, and that is equal to 1/3. So we've got here an algebraic fraction to solve now. So let's multiply these together. So we're going to have 5 times 6 is going to be 30 over n times n minus 1 is equal to a third. At this point, I can now cross multiply. So I'm going to have 3 times by 30 is going to be 90 is equal to n times n minus 1. I can now expand my bracket on the right hand side. So I get n squared minus n is equal to 90. And then finally, I take the 90 over the other side. So n squared minus n minus 90 is equal to 0 as required. And that is our part A done. And that's the question that was hugely controversial back in the day, as I say. The part B has been cropped off this image. I think part B was how many sweets are in the bag. So in order to work out how many sweets are in the bag, we need to solve this quadratic equation. And in order to solve this quadratic equation, we need to factorize it. Okay, so let's think about that. We're thinking about two numbers that times together to make 90, but add together to make minus 1. So they've got to times together to make minus 90, but they've got to add together to make minus 1. So let's think about what our factor pairs could be. We could have minus 10 and we could have plus 9. Let's check this as a pair. So 9 times minus 10 does in fact make minus 90. And minus 10 add 9 does in fact make minus 1. So that's our factorization. So n minus 10 and n plus 9 are going to go in there. Let's double check that that works again. So if I was to expand these brackets, I'd get n squared, I would get plus 9n, I would get minus 10n, and I would get minus 90, which would in fact give me that equation. So that means solving this now, that either n is equal to 10 or n is equal to minus 9. And we're going to rule that out because there's no such thing as minus 9 sweets. Having minus 9 sweets does not make sense in this context. Okay, I hope that you found that helpful. That's our introduction to the slightly more, well, a lot more difficult tree diagrams with algebraic fractions. And as I say, I'm going to produce a few videos on this topic because it is very, very, very popular with the exam boards and super important to know how to do. I'll see you in the next video.